Alright, welcome. In this video, I'm going to be working Algebra 2 Quiz 2.2, and that's the first of our two quizzes over three variable, three equation systems. And so we're going to start, I think it's just four systems, we're going to solve them. And so we're going to start with this first one, and we're going to look at these and say, what do we want to do? I think I'm going to eliminate z because I see this minus z and 2 plus z's, and I think it'll be pretty easy to eliminate these two z's using this negative 1z right here. So with that plan, I'm going to do equation 1 plus equation 3, right? I'm just going to copy them in. X plus y plus z equals 2, and x plus y minus z equals 0. Now, if you think you can add these two equations together mentally, you should do that, right? I just want to be as clear as possible about what I'm doing here. 2x plus 2y is going to equal 2. Okay, so that's got rid of z. Now I need to get rid of this z here in the 5x plus 3y plus z equals 5. So I'm going to copy down equation 2 and equation 3. That's 5x, 3y, 1z equaling 5. And x plus y minus z equals 0. Okay, add these together and I'll get 6x, 4y, no z's equaling 5. Okay. So now I have two of these equations, and I might call these equation 4 and equation 5. Okay. And so I'll need, if I want to eliminate, maybe I want to eliminate y on this one. I'm going to multiply this one by negative 2 and leave this one the same. So negative 2 of equation 4 plus equation 5 will eliminate y. But you could have eliminated x if you wanted by multiplying equation 1 by negative 3. Or equation 4, pardon me. So negative 2 of equation 4 is going to be negative 4x, negative 4y equaling negative 4. And then I'll have positive 6x, positive 4y equaling 5. And then I'll add these together. I'll get 6x minus 4x. That's 2x, no y's, equaling 1. Okay, divide both sides by 2, and I see x is equal to 1/2. Nothing wrong with that. And then I'm going to go back into one of my equations up here. One of my equations has two variables in it to find out the value of y. And then since I eliminated z at the beginning, that's going to be the variable I find last. Okay, so I'll do 2x plus 2y equals 2. So 2x is going to be 2 times 1/2 plus 2y, that's going to equal 2. And so that's going to be 1 plus 2y equals 2. And subtract 1 from both sides, and I'll get 2y equals 1. And then I'm going to divide both sides by 2 to solve for y. And I'll get y is also equal to 1/2. Okay, that's fine. And then I'll go back to one of my original equations, probably x plus y plus z equals 2. That looks like the easiest to deal with. X is 1/2 plus y is also 1/2 plus z equals 2. And so that's 1 plus z equals 2. Okay, that means z needs to equal 1. And my solution is x is 1/2, y is 1/2, and z is equal to 1. Right, and if we needed to check this equation, okay, well, I probably wouldn't need to check it on x plus y plus z equals 2, because that was how I figured out the third one, so it's going to look right even if I'm wrong. I should check it against this one. So 5x is 5/2, 2.5, plus 3/2 is 1.5, so I'm at a total of 4, plus 1 is equal to 5, that's good. 1/2 plus 1/2 is 1, minus 1 is equal to 0. Okay, good. I'm confident in my solution. Yeah, I'm not going to do that every time, but I am just reminding you that that is something you can do if you're ever unsure of your solution. And I remember some people coming to me and saying that they were unsure of their solution because they didn't get integers. Okay, so that's a way that we can be sure. All right. I'm thinking, doesn't really matter. I could eliminate z or I could eliminate x. It's going to go very similarly. So I might eliminate x. Okay, I'm going to do equation 1 plus equation 2. And that's going to be x plus y minus 2z equals 5. Negative x plus 2y plus z equals 2. Okay, I'm going to add these together. No x's, 3 y's, negative 1 z's equals 7. Okay, then I'm going to need to take 2 of equation 2 and add it to equation 3 to get rid of these 2 x's. All right, so 2 equation 2's is negative 2x plus 4y plus 2z equals 4, okay, 2 of equation 2, negative 2, positive 4, positive 2, positive 4, okay. And then just copy equation 3. Okay, and now I can add these together, right? And I have no x's, 7 y's, 1 z. And that would equal 4 plus 9 is 13. Okay. Now I might call this equation 4, and this one equation 5. And this is well set up for elimination. I've got minus z and plus z, so I'm just going to copy these in. Equation 4 plus equation 5. So that's 3y minus z equals 7, and 7y plus z equals 13. I'll add these together. I'll get a total of 10y, no z's, equaling 20. Okay, so I'll divide both sides by 2, and I'll get y equals 2. Okay. Now I'll go back to, I don't know, maybe this one. 7y is going to be 14, because 7 times y is 7 times 2, plus z equals 13. Okay, so I know 14 minus 1 is 13, so I know that z needs to be that minus 1. And now that I've got y and z, I'll go back to one of my original equations and solve for x. Maybe I'll do it on this one. So x plus y minus 2z is going to be minus 2 times negative 1, so it's going to be plus another 2 is equal to 5. So that's x plus 4 equals 5. Okay, x needs to equal 1. And then my solution here is 1 and 2 and negative 1. All right, solve the system of equations below. Okay, so I think what we knew at this point, I'm going to expect this one to come back no solution or infinitely many solutions. So I'm looking at this and I'm seeing some options, but really I think I'm going to eliminate on z. Okay, I see that minus z plus z minus 2z, I can work with these. Okay, so I'm going to add the first two equations together. And let's see, I'll have negative 3x minus 4y plus z equals 4, and 2x plus 3y minus z equals 3. All right, and then I'll have negative 1x minus 1y, no z's, equaling 7. And then if I take, say, 2 of equation 1 and add that to equation 3 to get rid of that 2z, I want a positive 2z so I can get 1 from there. I'd have negative 6x minus 8y plus 2z equaling 8. No, that's still visible to you. And then I'll copy in equation 3, 7x plus 9y negative 2z equals 2. And here I have x plus y, no z's, equaling 10. Yes, here we go. And then I'm going to add these two equations. These look like really well set up for elimination, right? So I'm not even gonna label these equation 4 and equation 5 because they're just like so perfectly set up for it. I add all this together and like, oh yes, here we go. Let's get it. It's 0x's plus 0y's equals 17. Like 0 equals 17. Oh yeah, that means no solution. Okay, so that just saves me work. I'm just going to write over here, there is no solution to this system, and I'm going to move on, right? Because 0 equals 17 is never true. Okay, number 4. Oh, I forgot. Yeah, this one's right, but don't solve. Yeah, these quizzes, they have 3 where you solve and 1 where you set it up. Okay. So there's going to be type A, type B, and type C. There's a total of 300 palm trees. And if all are, one of these 3 types, that means that the total of A plus B plus C is equal to 300. There are 3 times as many type A palms as there are type B palms. Okay, so it's going to either be A equals 3B or B equals 3A. And so you got to think, which one is bigger? There's 3 times as many type A palms. Okay, so there's more type A. So A is going to need to be equal to B multiplied by 3. Okay, because A is the bigger one. And buys all of the trees costing $12,300, and that's where all this price info came from down here. So that would be $30 times the number of type A's plus $45 times the number of type B's plus $75 times the number of type C's. That's the total number of dollars that you would get for selling all of the trees. And then you would get $12,300 And we could solve this system for A, B, and C to find out the price of each, but I wouldn't recommend it because it said write but don't solve, and I think I made these numbers up. So, and in general, if you just make up the numbers of a linear system, the solution in general is not going to be pretty. And so I wouldn't recommend you try to solve this. I don't think I caught anybody trying to solve it when we were grading these quizzes. This was a quiz that we did really well on. Before I move on to Form B, I forgot to say this at the beginning, but the way that we scored these, especially the system ones, was that we scored them out of 2 points, and the first point was eliminating down to a 2x2 system, or substituting down. But you had to get down to two equations and two variables. That got you the first point. And then the second point was your solution being correct. So if you saw that, if you didn't grade any quizzes and you got yours back and you saw that they were, this quiz was scored out of 8 and you were curious, that's how we scored those. So if you didn't get the right answer, but you did, do substitution or elimination, you should probably be seeing 1 out of 2 because you got down to a 2x2 presumably. If you didn't get that far, you probably didn't get any credit, but you didn't get really any way down the right road to the answer, so that's why that would happen. Okay, let's move on to Form B. That is not what I was expecting. That's 2b. I'm going to have to find myself a copy. All right, now let's work Form B. So I'm going to solve this system of equations. We're going to show the work that leads to our answer. I'm going to look and I'm going to think, do I want to do substitution? Do I want to do elimination? I'm probably going to want to do elimination because I pretty much always want to do elimination. And maybe I will do, I'm going to use this one. I'm going to eliminate, you can eliminate on x, y, or z, but I'm going to use this equation kind of as my tool because I would like to multiply this equation by different numbers. It would be very easy to do that. Okay, so I'm going to eliminate, let's just do z because I've got 2 positives and 1 negative, so that should work well. So equation 1 and then 3 of equation 3. Okay, so x minus 4y plus 3z equals 5. And x minus y minus, 3x minus 3y minus 3z equals 0. And that's still going to be 0 because 3 times 0 is 0. And I'm going to add these all together, and I'll get 4x negative 7 equaling 5. And then I'll do equation 2 plus 2 equation 3's. And I'll say, all right, equation 2 is 2x minus 5y plus 2z equals 6. And 2 of equation 3 would be 2x minus 2y minus 2z equals 0 again, because 2 times 0 is 0. I'm going to add these all together, and I'll get 4x, negative 7y, no z's equaling 6. It's like, oh, okay, well, I'll just copy them in here. 4x minus 7y equals 6. This looks like pretty set up for elimination. Maybe I'll multiply this one by negative 1. Negative 4x plus 7y equals negative 5. I add these all together. It looks like it's going to go well, and I get 0x's plus 0y's equals 1. And 0 is never equal to 1, so I know that this system has no solution. Okay, good. Saved us some more. Let's move on. All right, number 2, solve the system of equations. And I'm thinking I'm going to use elimination here. But if you wanted to use substitution, or if your first thought would be to use substitution, that's exactly what you should do, right? Always, your first instinct. That's going to give you the best chance of solving the problem accurately. So I'm over here, and I'm going to, I think, probably eliminate on z, because I would only have to multiply this one by 2 and 3, and these are all numbers that I can easily multiply by 2 and 3. All right, so I'm thinking 2 of equation 1 plus equation 2 to get rid of z. Nope, that wanted to be 4x minus 2y minus 2z. 4x minus 2y minus 2z equals 30. Yeah, that's 2 of equation 1. And then equation 2 is 4x, 10y, positive 2z. That's 10. All right. Pardon me, I'll try to make this look nicer the rest of the way through. So this is going to be 8x, 8y, no z's equaling 40. Okay. Then I'm going to eliminate z from equation 3. So I'm going to need 3 of equation 1. And maybe to keep myself from having the same issue, I'm going to start by doing that. If you find yourself I don't know, making errors at this step, you can do them one equation at a time. 3 of equation 1 is 6x, negative 3y, negative 3z equaling 45. And then I'm going to add that to equation 3 to kill off those 3 z's here, which is just negative x minus 4y plus 3z equaling negative 20. Okay, now I will eliminate my z, and I'll have 5x negative 7y equaling 25. Okay, now at this point, I can go a few different directions. I think because 8 divides 40, I'm thinking I might want to multiply this whole equation by 1/8. I know that might not be something that y'all would think to do right at this point, but it would make it it'll keep my numbers lower when I go to scale up to match up with that 7, or if I want to eliminate on x with the negative 5. So I'm going to take this one, and I'm going to take equation 4, and if this one's equation 4, then this one's going to be equation 5, and then I will multiply 1/8 of equation 4, and maybe sure. That'll be 1x plus 1y equals 5. And I mean, if you want to do substitution here, that's something you could definitely do. But I'm, a big elimination guy, so I'm going to do, now I'm going to call this equation 6. And now I'm going to do, let's see, negative 7 of equation 6 plus, so that'd be negative 7x, negative 7y equaling negative 35. And then I would have, plus equation 5 is 5x. So I guess I really just wanted positive 7 of equation 6. Okay, but that's all right. I can go and make that change pretty easily. 5x minus 7y equals 25. And then I will get 12x equals 60. Okay, divide both sides by 12, and x is going to equal 5. Then x plus y needs to equal 5, so that makes me think that y is going to equal 5. And then, just go to one of my original equations to find z. I might use the first one. 2x is 10, minus y is minus 0, minus z equals 15. So that would make it look like, okay, well, I subtract 10 from both sides, and I get negative z equals 5. So that would be z equals negative 5. Wait. I did something wrong here. X equals 5. Y needs to equal 0. Okay, I said it. I used it over there. I just wrote it wrong. Okay, let me make sure this is the right answer. Yes, that was what I got the other time I worked this problem. And so this is 5, 0, and negative 5. Okay. All right, that was number 2. Let's move on to the back. We're going to solve this system of equations. And let's see. I'm probably going to want to eliminate using, on z, probably using this one. And this is a very similar one to number 3 on the back side of Form A. Just think that these numbers are different, which I must have miscalculated because I think this is going to come back in a way I didn't intend it to. But I'm going to do equation 1 plus equation 2 to get rid of that z right there. So we have negative 3x, negative 4y, and a positive z equaling 4, 2x plus 3y minus z equaling negative 3. Add this all together. That's negative x minus y, no z's, equaling 1. Equation 2 of equation 1. Okay, this is where I didn't do it quite right last time, I think, is negative 6x minus 8y plus 2z equals 8. And then equation 3, right, because I need to have negative 2z, yes, that's the plan, negative x plus y minus 2z equals negative 1. All right, and I would get negative 7x, negative 7y equaling positive 7. Okay, and if I was to go and maybe I would call this equation 4, call this one equation 5, and maybe I wanted to eliminate x. Okay, I would probably multiply this one by -7, so I'd get positive 7x to go with that one. So positive 7x, positive 7y, I'm multiplying everything by -7 over here. So it's -7 of equation 4 plus equation 5. And I'd have -7x, -7y equaling positive 7. I add all this stuff together, and I'm going to get 0x's plus 0y. That must equal 0, because 0 times anything is 0, is going to be equal to 0. And that's always true, so there are infinitely many solutions. Okay, now what I will say about infinitely many solutions that I've said before is that if you add 2 of the 3x3 equations together and you get 0 equals 0, that's not always a guarantee that you are sitting on an infinitely many solutions case. Now, I'm not going to give you any of these like kind of fake ones. But if you whittle it down to a 2x2 and that one has infinitely many solutions, then you know that your 3x3 does also have infinitely many. Okay, so I know that I was good to stop at 0 equals 0 because it was 0 equals 0 after being at a 2x2. Okay, that's what I'm going to say about that. All right, number 4. This is one where we're going to set it up and not solve it. Okay, so there's type A trees, type B trees, and type C trees, and we want to know how many of each there are at the nursery. So if there's a total of 200, then A plus B plus C is going to equal 200. Okay, there are 3 times as many of type B as there are type C. So it's either going to be B equals 3C, or it's going to be 3B equals C. And so you got to think, which one has more? Well, if there's 3 times as many type B, there's more type B. So B is going to be C multiplied by 3, because that would be, well, more than C. And if you bought all of them at these prices, so 30 times the number of A's you bought plus 45 times the number of B's you bought plus 75 times the number of C's you bought and the total amount you spent, that would be $14,500. Okay, and that's going to be my 3x3 system that we could solve if we needed to, but it said don't solve, so don't solve it when it says not to, because in general, you just make up numbers of these, it's not going to come back well, like I said before. All right, that's going to be all for this quiz. Thanks for watching. Hope it helped if you missed any and you were wondering what the right answer was.